Number 1. It looks like the first like 10 of them are just deciding which kind of like hypothesis, test, or interval to use, right?
Yeah. Those ones are
Cool. So number
a little
1.
harder, I thought.
Let's see. In an article in the Journal of Small Business Management, in the U.S. and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the UK, U.S. and Korea. We want to determine if education level differs between managers of successful startup companies, differs between the two countries. Which hypothesis test would be more useful for the analysis? So we want the level of education and managers successfully starting up differing, or between the two countries differing?
I think between the two countries. I think between managers. Whoa. Between managers of successful startup companies differs between these two. Yeah, I just kind of assumed it was between the two countries. But that is kind of worded.
Because it says you want to determine if education level differs between managers of successful startup companies differs between the two countries.
It must be like a typo because that last sentence, the second to last sentence, just makes no sense.
Yeah, it just doesn't really make sense. I'm assuming it's between the two countries.
Yeah. I just answered it under that assumption.
So, with it being the difference, it's not chi-square, I don't think, is it? No, it's not chi-square. Maybe.
I answered G for this one, but
chi-square you have.
Guess.
That's the test of two proportions. Maybe.
Yeah.
I don't think it's the test of two proportions, though.
No.
Let me go to the review. Show summaries. I feel like chi-square test of independence, maybe. But they also want the difference, so it could be really interesting.
Yeah.
Conducting hypothesis test using two proportions, the null hypothesis is always P1 equals P2, indicating there's no difference between the two proportions. Maybe it is the two proportion one, because that one is looking for the difference of the proportions.
Right. And that one kind of, those proportion tests kind of fall under qualitative tests, not necessarily quantitative. Because we're trying to figure out how much education each person has, so it's not really a defined number. So that's why I guessed that.
Yeah. That's why I was thinking chi-squared, because it would be the education level of the United States is the same as the null hypothesis would have been like the education level in the U.S. and the education level in Korea are independent or are not independent.
Mm-hmm. Yeah.
No, that makes it hard because none of the two proportions make sense.
Yeah, I always thought these questions were kind of easy, but they're kind of hard now. This is like a lot.
I'm just not a big fan of these questions because they're word questions.
Yeah.
Example, no. maybe the ANOVA test?
See, the ANOVA test is when it's 3 or more samples. I think there's only 2.
Because it says one set of data compared educational level, and it's high school, undergrad, master's, and doctorate of people who manage successful startup companies in the U.S. and Korea. So since there's 4 educational levels that we're comparing.
Can you imagine? One set of data compared educational. Oh yeah, maybe it is. Maybe it is ANOVA.
Because we're looking at the different education levels in the 2 countries.
Yeah.
So I feel like ANOVA would make more sense.
Yeah. Yeah, let's go with that, yeah.
Okay. So number 2 then. Human Resource Manager reported data from a recent involuntary reduction in force at her company. You're an attorney and want to determine if age discrimination was a factor. The company reported that the number of employees in 2 years, 40 years younger, 40 years older. You reported the number of employees in each group were determined. Well, this one's that both groups treated equally. So would this be an independent sample one, just because you're 2 different groups that you're looking just to see if they were treated equally?
Mm-hmm. Yeah, they're going to be independent. Let's see, those are employees. Let me read this again. I would almost say it's like test of 2 proportions again, and the reason why is just because, again, I think they separated 2 groups of ages, but they want to find if each group was treated equally, unless they do that by getting a number of people who are fired.
Well, they would end up getting a number for it,
Right?
Because they reported the number of employees in each group who were terminated.
Right. Okay. Yeah. So then, yeah, I guess it would be independent.
That's why I'm thinking independent.
Okay. Yeah, let's go with that.
Okay, so number 3, survey was conducted by a group of state lotteries. Random sample of 2,046 adults completed the survey. Of the total, 240 were classified as heavy players. Of these, 152 are male. To determine the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Well, this one's to determine the proportion, so this one's one of the proportion tests, and so I'm thinking it's the one proportion one.
Yeah, that's actually what I guessed too. It was F.
Because the one group of males, and you're just looking for the proportion.
Yeah.
Okay, so a student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given a combination lock, the combination to each lock, and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. I don't know. I feel like this would be a paired sample test.
That's kind of where my where I'm leading to. Let's see. Still, I want to make sense.
Because it'd be the difference between the two, which would tell us whether it was easier to open or not.
Yeah.
Well, maybe. Just kidding. It'd be 2 sample t-test.
2 sample t-tests.
Which, just kidding, that's not on.
Yeah.
Out of the ones given, I would say it'd be the independent or the paired samples.
The paired, yeah. That's kind of where I'm going to. Seems like the best answer.
Yeah. Okay, so number 5 then. Let's see. Employs 2 appraisers. When approving borrowers for mortgages, it's imperative that the appraisers value the same types of properties consistently. To make sure in this case the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for the study? I feel like it'd be the +4 for 2 proportions. Because that gives a more accurate confidence interval, and there's 2 different appraisers that we're looking at it.
Yeah, and they need to be like equal. The 2 appraisers need to value the property the same, right?
Yeah.
Yeah, and so that one. So like the null hypothesis for that would be like, just,
What is
P1 is equal to P2 or whatever it is, so it has to be equal. Okay. So it would be F then.
Yeah. Okay, so number 6, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors were reporting that they were satisfied or very satisfied with their career path as was reported. The same data was also reported for accounting majors. You decide to construct 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for the study? That would be paired samples, because paired samples is the one that you get for the difference.
For the difference, okay.
Let's see. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. Me and some friends decide you want to know if that's true assertion by the company who makes them. You take a stack of 55 double stuffed Oreo cookies and measure out the filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for the study?
Estimate the true mean.
I feel like this would be a 1 sample T confidence interval.
Yeah.
Because then you'd get a 1 sample T confidence interval of the regular Oreos, and then you could compare them.
Oh, so you're okay. So are they okay? So are they only just testing just the 55 double stuffed Oreos?
Yeah.
Oh, okay.
Because you want to estimate the true mean filling of double stuffed Oreos in order to compare it to the filling amount found in regular Oreos.
Right. Okay. I thought they were testing both of them, so yeah, that makes more sense. So it's a 1 sample T confidence interval?
Yeah, 1 sample T, not Z, because we don't have a known sigma.
Okay, and the T confidence is when we don't know.
Yeah.
The sigma is.
The unknown standard deviation.
Okay, we're done.
Yeah. Number 8, which one of the following best defines the notion of significance level of a hypothesis test? Probably objecting no, sure not.
Oh yeah, this one.
It's B.
Yeah. Wait. I think it's A for 8.
Well, your significance level is just saying whether or not that the statistic that you have is more than the one you actually have obtained, assuming that the null is true. And that's what the significance level is telling you.
So it is B? Or?
Yeah. It should be B.
Because the reading said...
I read that in a lesson. Which lesson did I read that in?
I did too. Let's see.
I want to say it was lesson 17.
Okay, so found in lesson 2, it talks about the p-value. Says the p-value is the probability of obtaining a result called a test statistic, at least as extreme as the one you calculated, assuming the null hypothesis is true.
Yeah. Then that's basically what B says.
And
plus when you Google definition of a significance level of a hypothesis test, it brings up B.
okay, is this for question 8 or 9?
Question 8. 9 is just defines the best notion of a p-value of a hypothesis test.
Which?
And the p-value
B?
is the probability of committing the type 1 error, isn't it?
The p-value?
I thought so.
No, I mean, I just read the definition of p-value, and it says like, statistic more extreme than the one actually obtained.
P-value is the one that is at least as extreme?
Yeah, well, it's in lesson 2. I'm reading that right now.
Well, then is the significance level the probability of the type 1 error?
It must be. The probability of obtaining was it's true.
Okay. Yeah, so 8 should be C and 9 should be B.
Okay.
And then 10. Suppose you create a 95% confidence interval for a mean and you get 10, 20. You've been told to report this saying something similar to, we are 95% confident that the true mean is between 10 and 20. What exactly does that mean? That should mean that 95% of all 95% confidence intervals actually contain the true mean. I'm pretty sure it's D.
Okay. Yeah.
Let's see. Take a single random sample of 100 adults from a town in the western U.S. to determine the proportion of adults in the town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is 30%. What is the mean of the distribution of the sample proportions? Except, let's see. How'd you do number 11?
Yeah, honestly, I just guessed on this one too. I've never even seen a question
Okay.
like this before. Yeah. Yeah, I think this was the last one I answered and stuff, so that's as far as I got.
Okay.
I just guessed A, but yeah, I don't even know why. How do you even...
I'm pretty sure that it should be D, actually.
Yeah.
Because P hat and P... Oh, dang it. What was that? It was in the lesson.
Oh, yeah. It should, like, they're kind of somewhat... Oh, yeah. I think it is D.
The sample proportion P hat is 1 point on the number line that estimates the value of the true proportion P. So if we don't have a number to calculate for P hat, the point estimate for P is P hat.
Yeah.
So it should be D.
Yeah.
And then what is the standard deviation of the distribution of the sample proportions? Ah, dang it.
Yeah, this one was hard because I had no idea where to start. Like what standard deviation is.
I'm pretty sure it's B.
Yeah, I'll go with that.
Yeah, when you type in the numbers to the Excel spreadsheet, you get 0.046, and it's B.
Okay.
What is the probability that a random sample of 100 adults will have a sample proportion that is less than 0.25? So let me change this.
Did you use the
0.25.
quantitative inference or the
Less than
data?
yeah, it's the categorical data analysis worksheet.
Okay.
Um, well, for the Z value, I got negative 1.09, but I'm typing in that into the applet right now to see what the probability actually is.
Did you just use the one proportion sheet?
Yeah.
Okay.
Because we only have one set of data.
Yeah.
Oh my goodness. I got 0.1376 finally,
0.376.
which would be answer A.
So, yeah. So I'm trying to fill in all the information on the Excel worksheet. So the sample would be 100, right? Because that's all we've got.
Yeah.
And okay.
And then where X is, that's where you put like the 0.30 for the first one, and then it tells you about the 0.25, and that's where you put that.
Oh, okay. Is there? So I'm supposed to put in the null hypothesis part, or?
Yeah, the null hypothesis needs to be 0.302.
Oh, also. Ah, there we go. Closer. Okay, cool. That makes sense.
Yeah.
Awesome.
So let's see, for question 14, Acupril is meant to control hypertension. What? In clinical trials of this drug. Okay, so for 14, P1 is the proportion while taking this one, so this is, okay, true proportion of people who were not on Acupril. Create a 95% confidence interval for P1 to P2. Oh, what am I doing? I can type this in. X1, 61, N1, 1563. X2, 15, N2, 579. Okay, so the confidence interval, it looks like is negative 0.004 to 0.029.
Let's see. Yeah, that's what I got.
So C. Perform a hypothesis test to see if the proportion of the experimental group subjects who experience dizziness is different from the proportion of the control subjects who do. P1 is people on Acupril, and P2 is the placebo people. Significance level of 0.05. So which of the following pairs of hypotheses is most appropriate for addressing this question? It should be O. Control C that. It looks like B.
Yeah, I was going towards that too.
Yeah, it has to be B. None of the other ones work.
Yeah.
So, typing that in, p-value should be 0.145. Yep, D.
D?
Yeah.
Oh, yeah. Yep, okay.
Oh, yeah.
Yeah.
So the Z, which is the test statistic, is 1.458, and the p-value is 0.145, which is D as well for 17.
Yeah. I think 18 would be letter E. The p-value.
0.145. That's greater than that's greater. 0.145 is greater than the significance level of 0.05. So we'd fail to reject the null.
Different.
Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? Well, we failed to reject the null saying that they're the same, so I would say E2.
Okay.
(19 through 22). I feel like this is going to be a chi-squared test. Okay. Yeah, this is definitely a chi-squared test. And let's calculate the test statistic for this hypothesis test. I got A.
I did too.
Okay.
6.580.
Yeah. And then the p-value, I got 0.0866.
0.0866.
So it would be D, 0.087.
Yep.
Should we reject the null or not?
Still over 0.05.
So we would fail to reject the null.
Yeah. Checked. No. P-value is greater than 105. So
Yep.
E.
E is. 22. Do we have sufficient evidence to conclude that the age makes a difference in whether a person is a morning person or a night person? Why or why not? No, because we failed to reject the null.
Yeah.
Okay. A recent book noted that only... What? Okay, a recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of the sample, a 95% confidence interval for P. Oh, crap. So this should be a one proportion test again.
Yeah. So 50 out of 200.
No. N is 200. 50 if they're not performed. I got 0.195 to 0.315.
Okay. I'm still working on it. 20%. Oh wait, maybe I did it wrong. Gosh. So X is just 50, right?
Yeah.
Okay. And then null hypothesis would just be 50? Or is it point?
No, it's 0.20 because it's 20%. So that only 20% of the investment managers outperform the Dow Jones Industrial Average. So that would be our null.
Okay. What did you get for the confidence interval again?
0.195 to 0.315.
Okay. What the heck? Oh my goodness. Give me a second.
No, you're fine.
Hello? Yeah. Uh-huh. Really? Okay. 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 Do you want me to... Okay. 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 Sounds good. Thanks, Dad. Bye. Sorry about that. Yeah, I keep getting. Like, I'm not getting the right.
X should be 50, N 200.
Oh, 200 or 100?
Null hypothesis. Yeah, N equals 200.
Oh. Oh, well, there we go. All right. 0.195.
Yep.
Let's see. Cool. Suppose you had been charged in designing the study with sample size by meaning constructed margin of error of 2% with 95% confidence. Using the prior estimate, P star equals 0.2 for this estimate. Sample size will be needed to construct a margin of error of 2%. Where do you find the margin of error again on the z-test sheet? Because
Oh, for number 4 or 24?
Yeah.
That's just the formula N equals the z-score divided by 2 times the margin of error, and all of that squared. And it tells you that the margin of error is 2%, or that they want 2% margin of error.
Okay.
So it'd be 0.02.
0.02.
Yeah.
Suppose you have been charged with 10 seconds.
What'd you get for 24?
I'm still getting it. A for 2401.
Yep, that's what I got.
Oh, awesome. Cool. Alright, which is the founder's office is the most appropriate for addressing this question? So 25, would that be B?
B? Yeah.
Yeah. Okay.
And then 26, it's just asking for the requirements, and that should be C.
C? Yeah. Okay. Your test statistic. Test statistic.
The test statistic, just make sure that your one sample Z test for a proportion, that your numbers are still 50, 200, 0.95, 0.20, and then not equal to, and then you just use the Z-score and the p-value for 27 and 28.
Okay. Well, I'm going to get a z-score of 0, a p-value of 1. I'm not equal to 0.2 for my null hypothesis, and then 50 over 200. It's giving me this crap. Why is it doing this? value your test statistics. Okay. Okay, cool. So 27 is A and then 28 is D, right?
Yep.
Awesome. Like quit out of Excel and get back on it again. Sufficient evidence include. There's. No, so we'd still fail to reject.
Yep.
Yep. Awesome. Holy heavens, how many questions are there? All right. What's that?
Looks like these next ones we need to open the data file, the blue scores.
Yeah. So. Blue scores. Oh my gosh, what's going on? Computer software is commonly used to translate text from one language to another as part of its PhD thesis. So we'd have to use the quantitative Excel sheet, right? Quantitative inferences.
Yeah, and this should be the one sample t-test.
Yeah. What to say? I don't think that was going to fit on a chi-squared.
What time can you park on the, like at the school without permit?
Sure.
I think
Have you gotten the confidence interval for number 30 yet?
Yeah, I think I did. I have them, but
What'd you get?
confidence interval. So 0.282 and 0.293.
That's close to what I got.
Close? Okay. So let's see if I'm missing.
What'd you type in under the one sample t-test? Your confidence level.
0.95.
Yeah, and your null hypothesis should be 0.295.
Yeah, I did that.
And then type of test is not equal to.
Not equal to. Yep.
And then I got 0.278 to 0.292.
Let's see if the numbers again. Maybe it'll change. Okay, so yeah, I'm still getting the same thing. Let me try and quit off it and then go back on and see if it changes.
Okay.
It's the dumbest thing in the world because it should just work. I wonder if that's like been the reason why I haven't been getting a good score on my tests, is because of this maybe.
I don't know. That's really weird that yours doesn't get the same answers mine does. It's the same
Yeah.
worksheet that should out for both of us.
Mm-hmm. Okay, come on. Sample t-test. What the heck? Yeah, I'm still getting the same thing. Just to do this. Oh, wait, hold on. Yeah. The same thing. Okay. Okay. So what did you get for the degrees of freedom?
99.
Okay, I got that too. And then
And then the test statistic should be negative 2.721.
721. Okay, I got negative 2.803. Give me a second. I'm getting a call. Hey there. Yeah. I think it's just 3 4s, but hey, I can check. Yeah. Okay. Okay. Bye. Thank you.
What'd you get for the p-value on that one?
I got 0.0060.
Because on that one I got 0.0076.
Alright. Let me try something crazy. Okay. Let's see. Can you see my screen?
Let me actually pull up the...
Yeah, the video thing.
Yeah. No, I can't.
You can't?
Oh, just kidding. There it is.
Okay. So, yeah, this is all the stuff I typed in.
Give my computer just a second to actually figure out what's going on here.
Okay.
Well, I could see it for a second. Now it's gone again.
Uh,
Oh, there it is.
maybe I have to leave my screen up. That was my bad.
That's fine. So... Oh my goodness, this thing is so dumb. What try and do is go back to your blue scores and recopy and paste those over.
Okay.
And like, don't delete the ones that are in there first. Just paste on top of it.
Okay. it didn't change it. Ah, boy. That's kind of a bummer.
Yeah.
The kind of stuff I have to work with, and you know, just during the exam. Maybe that's why. I don't know.
I see if it still doesn't work, I know that Jay's and mine usually matched up, so maybe try like deleting the link that you have and
Yeah.
re-downloading it from the zip file.
Yeah, that actually thought crossed my mind too. Yeah. All right. So, but you got 0.293 for the other interval, right?
I got wait, the confidence interval it was 0.278 to 0.292.
Oh. Yeah, I'll probably just have to delete this or something.
Yeah.
Stuff, but yeah, I guess we'll just move on.
Then you had the right degrees of freedom, that was 99.
Yeah.
And then the T score should be negative 2.721.
2.721. Awesome.
With a p-value of 0.0077.
The p-value is 0.007?
Yeah.
Okay.
Or, well, I guess if it rounds, it'd be 0.008. Because
Okay.
it's 0.0076.
Okay. So then, yeah, so we reject the null. And then,
Yep.
so we have sufficient evidence to say the true mean is equal to A. Okay.
You say what?
33 is A, correct?
No.
No?
Well, we reject the null, and the null is saying that it was equal to 2.295. So it should be D, so we have sufficient evidence to say that the true mean is different than 0.295.
Right. Okay.
Since your Excel stuff isn't working,
Mhm.
do you want? I've already got those numbers. Do you want to just use the numbers I have, and then you can re-download it and we can check them again?
Yeah, that sounds good.
Okay. So for 34, I got 40.
So I think we lost connection there for a sec.
No, that's totally fine. Do you have 34?
No.
Okay. 8.728
8.728. All right.
to 10.455.
10.455.
And then 35, I got 22.446.
22.446.
We didn't even have to do 30 through 38 for the homework quiz. I just opened it up and it stops after question 29.
Oh, all right. That's good.
Are you just putting your answers in over on the quiz?
Yeah.
Okay.
And are they just the same?
For the most part, the numbers are different. Like number 21 on the quiz is number 18 on our exam review.
Okay.
Oops, she added an extra one in here.
Really?
Yeah, number 9's not on our thing.
Okay. Gosh. That is annoying.
And she added number 6 in here too, because number 6 we don't have either.
Oh gosh. So guess we have to do all this over again. Sort of.
Potentially.
Necessary.
So let's see. For number 6, it says weight gain during pregnancy of the mother is an important indicator of infant health. A simple random sample of pregnant women in Egypt, Kenya, and Mexico were used to determine if weight gain during pregnancy differed in these 3 countries. Which hypothesis test would be most appropriate for the analysis?
ANOVA. I think.
ANOVA, yeah. Okay, I think number 9 was the other different one. Yeah. It says O'Hare International Airport in Chicago has a reputation of having a large proportion of its flights being late. You design a study to see if this reputation is deserved. You find the average on-time rate for all international airports in the U.S. is 70%. You collect data and determine the on-time rate for O'Hare. You decide to construct a confidence interval to compare O'Hare's on-time rate to the national average. Which confidence interval would be most appropriate for this study? Probably E, the +4 confidence interval for one proportion.
Okay.
I would think. Yeah, E.
Okay.
Let's see. Do you already have the rest of it in, or do we want to go over the answers?
We should probably go over it. Yeah, because I don't know. I lost track of which one's down. So.
Okay. I'll go through it then. 2E.
Okay.
3D. 4F.
All right.
5C. 6E. 7F.
7F.
Yes.
Okay.
And 8C.
8C. All right.
9E.
9E. Okay.
10B.
10B.
11 should be the probability of committing, or probability of the type 1 error.
Okay.
12, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Okay.
13, 95% of all 95% confidence intervals actually contain the true mean.
Okay.
14 is 0.3.
Standard deviation.
15 should be 0.046.
Okay.
16 is 0.138.
0.1.
17 is negative 0.004 to 0.029.
Okay.
18, the null is P1 equals P2, and the alternative is P1 does not equal P2.
Okay.
19 is 1.458.
1.458.
20 is 0.145. 21 is no, I failed to reject the null.
Okay.
22 would be 6.580.
580. Okay.
23 is 0.087.
0.87.
24 is no, the p-value is greater than 0.05.
Okay.
25 is no, I failed to reject the null.
Okay.
26 is 0.195 to 0.315.
Okay.
27 is 2401.
Got it.
28 is the null is p equals 0.2, and the alternative is p does not equal 0.2.
Okay.
29 is n times p is greater than equal to 10, and n times 1 minus p is greater than equal to 10.
Okay.
And then 30, 1.768.
1.768.
31 is 0.077.
0.0.
77.
Alright.
And 32 is no, I failed to reject the null.
Failed to reject. Awesome. Alrighty then.
And I'm submitting it.
Yeah, me too.
Oh, well. I think we missed some of the, we missed some of the ones at the beginning. What else did we miss? Oh, well, we got 27 wrong.
Really?
Yeah, and 28 too. I'm not sure how though.
Yeah. 31 and 32?
We missed 31 and 32.
Yeah.
Oh well, if we had the wrong greater than or less than test, we would have missed all of that. Yeah.
Yeah.
Oh well.
Oh well. Yeah. So, yeah, is tomorrow the only time we can take the exam?
Well, it's open already.
Oh, it's open already.
Yeah, it opened last night at like 11:55.
Okay. All right. And then it closes and...
It closes tomorrow.
Okay.
Yeah. And then for the thing that's due Saturday, Have you looked at that yet?
No, I haven't.
Describe the data. There's something about we need to make the we need to make like charts and stuff.
Okay.
And
So this is describe the data or collect the data?
it should be describe the data. Collect the data was last Saturday.
Okay.
Oh, when this move it up.
No more than 2 pages. Describe the data you collected. Summarize your data in 2-3 paragraphs. Wait, what?
Yeah, we'd
2-3
write a couple paragraphs.
Yeah.
And we have to make charts.
Okay. All right. So let's see. What kind of should we just make like histogram or bar charts? Stuff like that, or like a pie chart would be better.
I don't remember what kind of test were we going for. Was it the difference? Or just to see if there was one that had more than the other?
Yeah, it was like specific colors. It was like pink and yellow or something like that.
Yeah, it was pink and orange to see something.
Yeah.
Maybe I should actually open that document and read it. And I know the graphs, we can make them. She gave us an Excel file so we could make the graphs.
You did?
Trying to remember what it's called. Let me see if I can find it. It is the quantity